two ways to solve this one. Now you can use your instinctual graphing knowledge. Now again, you don't want to necessarily be dependent exactly on a precise graph, but by knowing how these all look as graphs, that and how they translate based on whether or not the -2 is within a parentheses or not, and what it means to be x squared versus an absolute value versus an x cubed, that's going to tell you everything you need to know in regards to being able to get yourself a place where we know that y is always greater than or equal to 1, or essentially where is the graph always positive. That's fancy for when is the graph always positive. Well, if it is absolute value, that means that the shape looks like this going through the origin is what the standard shape would look like. Because it's -2, that means that and it's not in parentheses, it's going down 2 spots. That means that our graph is essentially now hitting a negative spot. Gonzo, right? Now we look at this one. This is a parabola. We see that often on the SAT, so we should feel familiar with that. And I'll draw a regular parabola, but it's -2, not within a parentheses. And again, it's actually the same thing as our absolute value. It's just not as sharp, but the translation is exactly the same, down by 2. It's now in the negative zone, the danger zone, and it's gone. Then we have here x -2, and that is now within the parentheses. And what it tells us is that essentially we're actually going to have an x term that's squared. So if you were to FOIL that out, square the first, square the last, multiply for the middle, and double the fast, that's not even important. What's important here is that we see that it's a parabola that's just going to be moving to the left, but I'm sorry, to the right by 2, to the right by 2. And that means that it's still above 0. And it's funny, whether it's left or right, it doesn't really even matter. It's above the x-axis. It's not hitting any of these negative components. So that means that it is correct. If it is a x to the cubed power, that gives us a completely different shape. That gives us a shape that will end up going through the y-axis at that point. And you don't want to have that going through. That literally means that half of this entire, because it goes this way in infinity and this way in infinity. So that literally means that half of it is going into the negative realm for infinity. That sounds like the ending of like a Mortal Kombat fight. Now, how can you do that if you don't memorize that? Remember that they're asking for y to always be greater than or equal to -1. So that means that it's 0 or greater. That means that if we were to plug in a value for x, no matter what that value is, we should always get a positive result out of it. Well, so the question is, can I create a negative? That's really what you want to ask yourself. It's easier to disprove things in life than it is to prove them. And here, what can I subtract by 2 that would give me a negative? Well, I can put in 1 or even -1 here. That becomes now +1 because it's absolute value. So 1 minus 2 gives me -1, so it can't be a. Same thing if I plug in 1 for here. It's always the simplest numbers that usually get us through problems like this. 1 squared is just 1. 1 minus 2, that's -1. 1 minus 2 gives us -1, but -1 squared gives us +1. So that actually turns out to be correct. And then if I were to put in -1 here for x to the 3, that still ends up with -1 minus 2, which is -3. Even if you gave us +1, 1 minus, that's going to still give you D as being incorrect.